So before we dive in, I would like to, do you have an idea how many CNCF open source security projects exist today? So some examples. Keep in your mind these options. I'm going to give you a fast tip. Okay, done. So who in here think is A, between 27 and 47? Okay. B, 48, 74. Some of you, okay. C, some people just don't want to participate, right? So actually, the correct answer is between 75 and 95, and to be more precise, actually 80. Well, 80 since I built the slides some months ago. So as we know, open source projects in CNCF keep growing. So maybe we are around 82, 3, something like that. So I'm Bruno Gabriel da Silva. I'm a senior solution engineer on a company called Sysdig, where I help customers to secure their workload and compliance, their workload and Kubernetes and in the cloud. Funny thing that I started to work with Kubernetes because of Windows. So some years ago, I worked on AWS and then on K8s 1.14, if not mistaken. Windows was support release, and I have a big Windows sysadmin background, and then my team said, hey, we don't know no one who knows this Windows stuff, and now it's even worse, it's Kubernetes with Windows, so can you please help? I was like, okay, so let's do the hard part. Let's learn Kubernetes, and then let's learn more deep about Linux, and then here I am. Today, we're going to talk about picking the right tool to secure a Kubernetes habitat, because, there's a lot of talks that we are, surviving day one, let's do this, and okay, my cluster is up and running, I'm okay, I'm happy. What is next? What is my next step that I should be doing? So in this case, you can see we're talking about security. So if you read what this talks about, the idea is really to try to, correlate how kind of animal kingdom or habitat works between tools. So I hope I got some ideas here and give you a reminder, how this thing is being connected. And why I think this is a nice way to do it is because, in animal kingdom, we have a lot of animals that they sound very similar. For example, a lion and a tiger. They even overlap in a lot of things, like they're from same family, etc. But the way they hunt, the way they, do their social life, let's say, then can be very different. And this is the similar thing would happen on open source, or even talk, let's say, about Kubernetes ecosystem. We saw, for example, we have outscalers, then we have HPA, VPA. Well, both are outscalers, but actually they're not the same. They're similar. So this is the idea I'm trying to bring it to clarify some tools that we have for security that can be a little bit overlapping and how they, specialize on it. Also, the tools, of course, we don't have time to cover all the 80 tools, otherwise it's going to be, how to see 80 security tools like in 20 minutes. I got a little bit of the experience that I had running these tools myself and customers that I see using in open source events like, like this one, KubeCon, etc. And of course, community usage. And there are so many tools for so many stages that I selected some that I think are really, specialized, or I would say essential when you talk about security on the Kubernetes world. In this case, we're going to go talk about build phase, deploy phase, start phase, which is sometimes not as, let's say, recognized as important, but we're going to see why, and then when we finally got to the runtime phase or running phase. Starting in the build phase. So here we can see we have, the blue square container, and we have the green square with the image. Why I would like to highlight very important this, I heard so many times events, people say, hey, I'm scanning my containers. I want to see the vulnerabilities of my containers. I understand that the person is actually saying to me, I want to see the vulnerabilities of my container image, but conceptual talking, a container is when the image is actually running. So we can see here that when it becomes a container, we're going to have what we call the runtime layer, which is we can read and write, which is what's between the brackets. And during the build phase, actually we're focused on this, the green square, when it's the image. Image, by definition, is something static, which you're going to have the layers. So we start, for example, layer 1. Maybe you cannot see correctly, but I'm going to read. So layer 1 from Alpine, so like a base operational system. On layer 2, I'm copying some JSON to etc app. Layer 3, I'm installing, let's call it this way, I'm adding this package or OpenJDK 11. And then in the layer 4, I'm copying / adding my application itself, my code that I developed to the path / app. And this, again, it's very important, is the image. When I get someone who's novice to the space of Kubernetes, and I like to explain the image is a little bit like doing a cake. So we get the Docker file, which could be the receipt of the cake. So the layer could be, let's say, I have the pan, then I'm going to add like sugar, milk, flour, and we're going to make this image or bake this image, or in the case we're going to build this image, and then the result's going to be the cake. Why I like to do this? Because if you forgot to add the sugar, after the cake is done, you can still add sugar, but the result's not going to be the same. Similar is to remember that images are immutable. So once I create it, if I need to do a change, like let's say I forgot to add my app on that, well, I need to rebuild. So it's very important. There's a big difference because, as you can see, it's really only between the image layers. Take a deeper look on the base image here. We are seeing what is the operational system, which is the foundation layer of the image. In this case, it's an Alpine, and you will see that this is what the root file system of Alpine has, like bin, etc, lib, etc. It could be Ubuntu, it could be, a Wolfie from ChainGuard. There's several base images you can use, and on top of that, you're going to build the layers to bring your application to life. Yeah, again, green square, container images, okay? We're going to have the layers. So we download these images from internet. Sometimes we just do a kubectl, apply some strange GitHub because we believe we're just testing, what could be wrong with that. And the thing is, if I don't own the pipeline, if I don't have the receipt, how do I gonna know what is inside? So going back to the cake, imagine I'm in the supermarket, I go to the shelf and get something to put topping of my cake. What I'm gonna see is like, hey, let me read the composition of that. I want to understand what's inside. Maybe I'm sugar intolerant, so I need to understand the composition, what is inside. We do the same for the images. But in this case, what we say here, we're going to scan the image to do that. When we scan the image, one of the very well-known, I would say, scanner image of the community is called Trivy. And here are the 4 main steps in a summarized way how Trivy performs text. So first, structuring the layers to understand what is base OS, what is not. Then we're going to build the file system. So if you remember what I showed before, kind of, let's say it was an Alpine, so we're going to rebuild the file system to understand, the folders, etc. It go identify OS and OS. This is something, again, very important based on the layer. And then we'll compare with the vulnerability DB. What is a vulnerability DB? Well, basically, when a CVE is discovered, let's say, Python has a package called Bruno 01. There's a CVE 2025-0101. Means that this package has this problem because if I use specific exploit, I'm able to have this vulnerability being abused. So the VulDB is kind of a catalog that say this package name, or this SBOON to be more precise, has this vulnerability attached, and then we do the cross-check to say what I'm instructing here, what I'm reading here, versus the vulnerability DB. This is kind of how it looks like the results of a scanning with Trivy. We can see that the base image, the Alpine, doesn't have vulnerability, but the PEEP and the setup tools, one has 1 vulnerability, other 2, while the other package, the wheel, doesn't have it. So this is very nice to understand where actually my vulnerability is coming from. Something that happens very often, the developer, he doesn't have intention, or mostly he doesn't have the intention to bring a vulnerability to the application, but that sometimes dependency can bring. I'm installing one thing, and then there's 10 extra things that come together as dependency, and they're going to be being together. The animal that I chose to represent this is a raccoon. So, a raccoon gets, a trash can. he's going to go and scavenge the trash can. He knows what he's looking for. And in his nature, he has this vulnerability that knows, like, hey, this is kind of, plastic or something. It's not a fruit or something that I should be eating or should be good for me. So I think it's smart to try to remember Trivy as a raccoon, like, get inside, open what's inside and see what's good or not. Moving to the deploy phase, when I send a request to Kubernetes, let's say kubectl apply -f -f bruno.1.yaml, let's say we're creating a pod, this request goes to Kube API. Kube API, by design, doesn't have a way to enforce policies or something before the deploy happens. This is where we can use something called the mission controller that's basically going to read the requests, and it could or could not make a modification. Some of the mission controllers are only used, for example, for logging or for compliance. So whatever goes to Kube API, get me a copy, and then send to, I don't know, to SIEM or something. After this, the mission controller logic happens, it will return to the state of Kubernetes, also known as etcd. But for a lot of companies, this is not enough. For example, if I create a pod missing a label, so I don't want to allow this to happen, I can enforce this, with a tool like Kyverno. So Kyverno can read the request based on a policy that I created, which is also the thing nice in Kyverno is the policy written in YAML, so very easy for the DevOps, let's say, language use in a lot of topics. With Kyverno, we're going to intercept and say, hey, if a label is missing, I can produce a warning, or most of the cases, I will block. It could be a little bit more enforced. For example, I don't want to allow privileged pods. So I don't want something that pods running with secure context not set. So secured settings as also policy sets like labels, etc. The other options on the mission controller, which also very used, is the mutating, which makes the name speaks for itself. I send a request, something's missing as per my policy, but instead of just deny, I will enforce something. Very common use case for that is using limits or requests. If you just send a pod without this, I'm going to mutate and say, okay, the default is you cannot go more than 1 CPU and more 1 gig of RAM. So I avoid this pod or this deployment to be very noisy on my environment. So this is the way, one of the ways you can use, and it's very recommended to have at least in warning mode, so you catch things, what's going on in your cluster. To correlate to Kyverno, for me, was a little bit of like, a forest guard, especially being here in the Bergen, you're going to do a hiking on the mountains. Imagine that you go to a specific, trail and say, hey, do you have the tickets? So I'm the mission controller, I'm the policy guy. Hey, do you have a ticket to go ahead? No, if you don't, you cannot go. Or we can be enforcing. For example, are you going to hiking at night in the mountains? Well, at least you should have like a lamp or a cell phone. Did you alert someone at your house that we're going alone? So all of this, it's enforced by, let's say, the city security principles. So this is something to kind of have correlated on your mind. So on the starting phase, Kubernetes have secrets. You may have known they are not so secret. It's just base64 way to encrypt something inside Kubernetes. But one of the problems we have actually on the Kubernetes is not the secret itself, is the way we use them. Meaning we mount this a volume on environment variable to don't put directly on hard-coded, which is less worse. But the problem is rotation. How do I rotate secrets in a safe way? Kubernetes doesn't have its own way to rotate the secrets. And by secure definitions, we usually save secrets on external sources. Some very well-known external sources are, for example, AWS Secrets Manager, HashiCorp Vault. There are several players. But in here, the tool that's very nice to be using is external secrets operator, which basically does for us this sync. Hey, goes to the repo, let's say Helm, or in this case AWS, was IAM authentication. So it's very good because I can implement security on this part. So some people can only read the secret, some people can update the secret, and then let external secrets do the sync between them. There is other techniques to bring secrets to Kubernetes, but what I really like on the external secrets operator is that your developer or The Kubernetes itself doesn't need to know this exists. It makes the sync, but the way the secret's mounted in the volume or environment variable doesn't change. So you don't need to create like CRDs and extension and add complexity. It's just you do the management outside with like GitOps approach, etc., and then he keeps doing this sync for you. He supports, cloud authentication, so it's a very nice way, and also auditability. When this was rotated, who rotate that, something that Kubernetes doesn't have. So to get an animal correlate to that, I think a squirrel could be something that correlates to this, because squirrels goes outside, get the things that's important for them secrets, and keep in sometimes not exactly in their home, but in a secret way. And when they need it, when they're hungry, they go there and get. So they keep their way they're working, but they keep this away from, let's say, the external place. So moving from start to runtime, well, we scan images, we had the admission policies, and we have my secret safes. We are safe, right? Right? Well, actually, kind of. When you go to the runtime phase and see the color again, yes, I know, I saw this seven times at least. Now we're moving to container phase, runtime. My image become, read and write, which means that could also bring extra problems because, now attackers or other things could happen while this image is running as a container. We are talking more about Kubernetes. So here we have, the pod representation. How can I monitor? How can I scan this thing happen? Well, I could use maybe an SDK or add a sidecar, but this adds a lot of complexity. The way that this pod, this container talks to the kernel, is by system calls. So instead of trying to intercepting this here, I can use something like Falco. Falco is an open source project, as the other one, that's based on this idea that, hey, instead of being a couple or like sidecar in each of the containers, actually I go to the kernel, which is the single source of truth, and using eBPF, or external Berkeley packet filter, is a way that we can talk to the kernel in a very light and safe way to understand what's happening with the syscalls. The thing about syscalls, like open file, read file, open connection, could be millions of syscalls in 1 minute of your machine. What makes Falco different is that he reads all the syscalls, but based on rules, he's going to generate an event. So, hey, open a file, close a file, yeah, okay, but this is very noisy. Well, someone wrote something on /tmp. Or someone install a new binary, someone download a binary, someone did a curl outbound to a specific DNS, which is a known C2 server on the internet, let me know. So this is where Falco can be very handy. One example that became very strong for Falco was the Nginx ingress nightmare, when if you scan the Nginx image, there is no vulnerability, because there was no package with a specific vulnerability to be attacked. The attack only happened at runtime because it's based on webhook behavior when the Nginx was running, and then Falco could be a tool that you can use for this case. Well, this one was the easy one to get the animal correlation, as the name itself comes from Falco, which Falco is Italian name for it. So the takeaways I want to have, yes, very, very important. Scan images are different than scan containers. The best practice can be enforced, so don't allow everyone do whatever they want. Keeping using external vaults without losing the Kubernetes native way. So again, on this one, when I did the research, a lot of people use another one, CRDs, but you need to change the deployment, you need to keep changing, and then with external secrets, just it's transparent for the cluster or for the, let's say, your final user. And then if these 3 layers is not enough, we then can get the runtime to the rescue. I will share the slides, some extra content. Thank you so much.